Hi, this is topic H. We're doing factored form and roots, okay? So just know that the roots become the factors, and when roots go into factored form, you got to change the sign, okay? That's the big idea. So let's look at the worked out example. The graph of g of x is shown to the right. Write a possible equation of g of x. So this worked out example has done exactly what we've done in class, right? You look at the root, you identify it. This root would be x equals -4. You look at the root, you identify it. This root is x equals 0. Sorry, you look at the root, you identify it. This root is x equals 3. Then you take the roots and you put them into factored form by adding parentheses, then changing the sign. So on the graph, it was -4, now it's a +4. On the graph, it was 3, now it's a -3. Now the funky one is that x equals 0 becomes just a plain old x, and that's because the factored form would just be x plus 0. And in math, we like to get rid of the stuff that we're not really using, right? Excuse me, and we'll get rid of it. So then we would just end up with an x. Tips. Switch the signs of the roots to get the factors. We talked about that. X equals -2 becomes x plus 2 in parentheses. If the function crosses at x equals 0, then the factor is just x. We went over that. And the axis of symmetry is halfway between the roots of a parabola. So this is just a reminder, right? If you have a parabola and he has roots of x equals 1 and x equals -1, the axis of symmetry would be halfway between the two, which is at x equals 0. It's the line where if you folded the parabola in half, there would be a mirror image on either side. Question 1. The zeros of the function f of x equals x squared plus 2x minus 3 are, well, in order to get the zeros, you can do two things. You can factor this guy, then set each factor equal to 0, right? This is when f of x equals 0 is what we're trying to find. Or, I'll show you the way to check it in a minute. Factors of 3 that add up to 2 are going to be positive 3 and negative 1. Do these add up to positive 2? They do. We're good. So our factors are x minus 1, x plus 3. We changed the f of x to a 0, and now I just split and solve. Set each linear factor equal to 0, then isolate your x. And the answer is x equals 1 and x equals -3. Which is this one. The way you could do it on your calculator quick without having to factor is you would take the original x squared plus 2x minus 3, you graph it, and you find the zeros. Menu 6, 1. There we go. And again, we got x equals -3 and x equals 1. Perfect. Let's look at question 2. Based on the graph below, which is a possible factorization of h of x. So factorization is just a fancy way of saying factored form. And the way we write factored form from the graph is by first identifying the roots. So this would be x equals -1, -2, -3, -1, -2, -3, -4, -5. You would have another one at x equals -1. And then another one at x equals 2. That would become x plus 5, x plus 1, x minus 2. So let's see where that one fits in. I need a plus 5, so I can eliminate this one and this one. I can eliminate this one because there's not 4 roots. This would have to be our answer. And you can double check. We changed the x equals -1 to x plus 1. We've changed the x equals 2 to x minus 2. And we've changed the x equals -5 to x plus 5. Perfect. The answer is choice 2. And now you can also check your answer and make sure you're right by graphing the answer choice 2 and seeing if it looks like the one that was given as h of x in the picture. So I'm going to type in x plus 1, and then I'm going to put a times in between the factors because sometimes the graph doesn't like, when you don't put the times, it says something called like implied multiplication or something like that. So just type in the times in between. And then now let's double check that we have the right roots, okay? They should match the roots we found in the picture. All right, so it's 2, -1, and 5. Yeah, that's what we had on the picture. Perfect. All right, let's do question 3. It says Keith determines the zeros of the function f of x to be -6 and 5. What could Keith's function be? So we're starting with the roots, same as always. We're going to put them into factored form by changing the sign and then labeling what we want it to be. This wants to be f of x. Okay, so our answer would be this one. Question 4. The graph of f of x is shown. Which function could represent the graph of f of x? Let's find the roots. X equals 1. X equals -2. X equals -4. Let's change those signs and put them into factored form. And then it wants to be called f of x. So there we go. Now I see an x plus or minus 2 out front. We have an x plus 2 in ours. So we're going to eliminate the ones with an x minus 2 because they don't have that. But then it looks like they took the remaining 2 factors here and then multiplied them out to make a trinomial. So let's do that and see if which trinomial these match, okay? So I'm going to take the x plus 4. I'm going to take the x minus 1, and I'm going to multiply them out. And I get x squared plus 3x minus 4, and that's going to match this one here. Okay.
So
Do you guys have something in here?
we have like a weird thing where I just thought we could stay in my room and do a movie because we were supposed to go on LeBeau Field, and the 3rd floor is closed. So she's like, Miss Shaw was like, "There's bathrooms that are open," so we're like trying to find one.
Yeah, you can come in, that's fine. I'm just finishing a video right now. Do you have kids waiting outside?
No, I don't.
Oh.
It's cookies for kids.
Oh, okay. All
I was
right.
gonna say I don't think we'll get kids. So.
Oh, okay, perfect, yeah.
Okay. Are you
The-
okay if I tell Shaw then?
Yeah,
Like,
that's
update
fine.
the sheet?
The graph of f of x is given below. Could the sorry for the interruption. It's all good, right? We're all here. The graph of f of x is given below. Could the equation of f of x be f of x equals x times x plus 3 times x plus 5 times x minus 2 times x minus 4? Based on the graph, explain why or why not. Well, first let's identify the roots given the picture. So I've got x equals, this is for this one here, -1, -2, -3, -4, -5. This one's going to be -1, -2, -3. This one's going to be x equals 0. Remember, he becomes a weird one. X equals 2 and x equals 4. So let's go ahead and put these into factored form with their flipped signs, and we'll just read from right to left to make sure we get them all. I have x plus 5, x plus 3, plain old x. That's for the x equals 0 one, don't forget. X minus 2, x minus 4. So let's go ahead and put the x in the front to kind of match their structure, right? Then they put x plus 3 next. Then they put x plus 5 next. Then they put x minus 2 next. Then they put x minus 4 next. Okay, so yeah, that could totally be the equation because it is the equation. So we could say, yes, that could be the equation. Because those factors match the roots. Okay, level 3, question 6. A polynomial function contains the factors x, x minus 2, and x plus 5. Which graphs below could represent the graph of this function? Oh, good.
Seniors, class of 2025, come on
Okay,
down to
so
Commons 2 to celebrate the annual
we're going to
Decision
turn
Day.
these into the
Regardless
zeros.
of what your plans are for after high school, we'd love to have you come and celebrate as a class together one last time before our graduation. Decision Day is now open in Commons 2.
You have one guess of what day I'm making this video on. Ready to go. Okay, so x equals 0, x equals 2, and x equals -5. So let's find the graph, first of all, that has 3 roots. That one doesn't. And we need one at 2, 0, and -5. Yes. Okay, it's 1. 1 only. How many real solutions does the equation x squared minus 2x plus 5 equals 0 have? Justify your answer. Let's graph it and see. X squared minus 2x plus 5. Oh, it has none. It has no real solutions. So you could either say I graphed it and it didn't touch the x-axis, or if you want to be super duper fancy, the discriminant tells us both the nature and number of roots. So if I take this quadratic and I have a equals 1, b equals -2, and c equals 5, and I plug it into the discriminant equation and I end up getting a negative number, that is also proof that there are no real solutions. So I'm going to do exactly that. I'm going to plug in a -2 for b, I'm going to plug in a 1 for a, and a 5 for c. I now have 4 minus 20, that's going to be -16, since the discriminant is negative, there are no real roots. All right, so remember, you write this is your justify, and you could always just say I graphed it and then draw the sketch if you want. Question 8, if the zeros of a quadratic function f, so it's f, okay, are -3 and 5, so I have x equals -3, write them in the form that's familiar to you so you can kind of just rely on your algorithm and you don't need to overthink it. What is the equation of the axis of symmetry? Well, the equation of the axis of symmetry is located exactly halfway between the two roots, so let's count in from each side and see where it would be. You could also do 5 minus -3 divided by 2, right? So that would end up being 8 over 2, which is 4. So there's going to be 4 pieces in on either side. 1, 2, 3, 4. 1, 2, 3, 4. So 5 minus 4 is going to get me to 1. 3 plus 4 is going to get me to 1. The equation of the axis of symmetry is x equals 1.